What is Quantum Entanglement? Part 2 by YKademy. Hey guys, this video is a part 2 of a 2-part series on quantum entanglement. If you haven't watched part 1, be sure to check it out. In this video, we will go over more on quantum entanglement and specifically 2 of its most important aspects. First, let's go over a couple rules we need to set due to complementarity and to avoid contradictions. We must admit that 1. A property that is not measured need not exist, and number 2, a measurement is an active process that alters the system being measured. Now, let's go over some of quantum entanglement's main characteristics, known as the Einstein-Podolsky-Rosen or EPR and the Greenberger-Horn-Zellinger or GHZ effects. Both have been checked in rigorous experiments. Though in actual experiments, people measure properties like the position and momentum of particles, the direction of their spin, or their energy and duration, rather than the shapes or colors of apples that we chose in our last video. The EPR described a startling effect, which consists of 2 quantum apples, or what we call quapples, each of which can be measured for its shape or color, but not for both. We assume that we have access to many such identical pairs, and we choose which measurements to make of their components. If we measure the shape of one member of an EPR pair, it is equally likely to be square or circular. If we measure the color, we find it's equally likely to be red or blue. However, when we measure both members for color or shape, we find that the results always agree. However, there is no correlation when we take different types of measurements. What does this mean? For example, if one is red, the latter 2 will be red. On the other hand, if we measure the color of one and then the shape of the other, there is no correlation. Thus, if the first is red, the second is equally likely to be square or circle. The same applies when measuring the shape of one and the color of the other. We will, according to quantum theory, get those results even if great distances separate the 2 systems, and those measurements are performed nearly simultaneously. The choice of measurement in one location appears to affect the state of the system in the other location. This is spooky action at a distance. The GHZ effect is another peculiar characteristic of quantum entanglement. It involves 3 of our quapples, paired in an entangled state. We distribute the 3 quapples to 3 distinct experimenters. Each experimenter chooses, independently and randomly, whether to measure its shape or color, and records the result, and this gets repeated many times. Each experimenter separately finds random results. When one measures the quapple shape, they're equally likely to find a square or a circle, but when they measure color, red or blue are equally likely. But later, when those experimenters come together and compare their measurements, there's a stunning result. Let us call square shapes and red colors as A, and circular shapes and blue colors as B. When 2 of the experimenters took the same measurement but the third took a different type of measurement, they found that exactly 0 or 2 of the results were B. But when all 3 chose the same type of measurement, they found that 1 or 3 of the measurements were B. That is what quantum mechanics predicts, and that is what is observed. This is important as a balance between A and B are affected by your measurement choices. Quantum entanglement is essentially a phenomenon where the quantum state of each particle cannot be described independently of the state of the others, even when separated by a large distance, and the measurements of the particles are correlated. That's all for this video, guys. Hope you all enjoyed the video, and if you did, be sure to like, comment, and subscribe.